All right, so as I mentioned, we are going to do the zero product property today. This is lesson 5 of our little unit here at the end of the day, or the end of the year. And we are going to continue working with quadratics. And today we're going to talk about this fancy term, zero product property. So as what we've done with most lessons, you're going to take some notes, follow along with examples, do your assignment, post it on your DUR. Okay? Kenzie, you okay over there? All right. So the first thing on the first slide, I've got some definitions, and then I do have one example that we're going to go through. It is a little lengthy only because it takes up quite a bit of space, but it's pretty straightforward with what we've already been doing. There's not a whole lot of newness today other than this term zero product property. Ian, you ready? Do you want to put your phone on my desk? Okay, can you put it away then? Thank you. Like really put it away? Like in your backpack maybe? All right, so draw that line 1/3, 2/3 on your paper. We're going to talk about the zero product property. So the first question is, what is it? And basically it just means this, that we know if you multiply two things together and the answer makes 0, one of those two things has to equal 0. So the product, right, when you multiply two or more numbers, so when the product is 0, one of those numbers has to equal 0. So if you think about what we've talked about with quadratics and working on factoring in your head, maybe you're thinking, oh, I bet one of those factors we're probably going to have to make them equal to 0. So you might see it officially written as if A times B equals 0, then either A equals 0 or B equals 0. Again, it just means when your answer is 0, when you multiply, one of the two things has to equal 0. Sometimes it's both. Again, remember, trying to abbreviate things as you take notes is always a good note-taking strategy. Using symbols, maybe for multiplication. Instead of the words must equal, maybe you can use an equal sign. If you're in person, when you're ready, give me a thumbs up, please. If you're at home, can you click the raise hand button and let me know you're ready? I got you. I got you, Kenzie. Thank you. Again, the phrase zero product property. If you see that it's a product equals 0, then one of those two parts of it has to equal 0. Those two factors. Again, if you're at home when you're ready, click that raise hand button, please. Here in school, if you can show me a thumbs up when you're ready for me to move on, that'd be great. All right, just about 15, 20 more seconds for you to get caught up, and then we're going to move on. All right, here we go. Next part. So when we talk about quadratic equations, we talk about something called the roots. So the next question is, what are the roots of a quadratic equation? If this was me and I was taking notes, I would probably just write the word roots, abbreviate quad, and then equation, as you guys know, I use EQN, and then put a question mark with it. Okay, so what are the roots of a quadratic equation? So the roots are also what we call solutions and they're the values of x that make the quadratic equation equal to 0. What do all those words mean? They're the solutions, and you're trying to find where x equals 0. That's it. So those are the roots. Roots and solutions are synonyms, right? Two words that mean the same thing, have the same meaning. Roots and solutions are interchangeable, and you're looking to find where x equals 0. Now, we're not going to get into graphing, but while you're writing those notes down, basically quadratics are a U-shaped graph, and what the solutions are is where that graph crosses the x-axis. And if you think about it, x equals 0, all those coordinate pairs that are on the x-axis are always 0, something. So that's what we're finding. That's what are considered the solutions to quadratics, or roots. Again, just like in the previous slide, when you're ready, show your thumbs up here in person. And if you're at home, click that raise hand button when you're ready to move on. All right, again, solutions are those roots. And again, we're going to find where x equals 0. And so we're going to use what we know about factoring and the zero product property to help us figure out. So here's the steps. There's 5 steps to finding the roots of a quadratic equation. Step number 1. You need to make sure, the very first thing that you need to make sure that you do is that one side of the equation equals 0. Sometimes you'll see it where there's a plain number on one side by itself, or there's a term with a variable. What all you need to do is use inverse operations so that one side equals 0. Step 1. Step number 2. You're going to factor the quadratic equation, and this is what we've been working on the last couple of weeks. When we hear the phrase or see the phrase factor the quadratic equation, that's where we do the x thing, right? The product of a times b that add up to c, or sorry, a times c that add up to b. We figure those two numbers, and then we do that square area model, right? That's what we mean by factoring the quadratic. So first thing, make sure one side's equal to 0. The second thing, you're going to factor that quadratic equation. The third thing, you're going to take each of those factors and set them equal to 0. So let's say you end up getting x plus 2 and x minus 9. You would take each of those factors, x plus 2 equals 0 and x minus 9 equals 0. And then you're going to solve. Solve each of them for x. And then step number 5. The solutions are just those values of x that you found. So you might say x equals -2 and +9 in the 2 examples that I just gave you. Yeah. So Sam said, so basically both sides have to equal 0. Yes. And so the only thing that's different today than what we've done up to this point is setting that equation equal to 0 and then finding the 2 values for x that make it work. Up to this point, we've just done the factoring. Today, we're going to add in solving it. Okay, so again, thumbs up here when you're ready, in person, and then at home, click that raise hand button when you're ready, please. Jesus, you okay, buddy? So again, steps 1 through 4 are the well, I shouldn't even say. Step 1 is newer today. Step 3 and step 4 are the new ones that we're adding in. You guys already know how to factor, and in my opinion, at this point in your mathematical careers, the factoring part is the most challenging piece of it. Because what's going to happen when you solve each of those factors, you're either going to do 1 or 2 steps to find x anyway. And I think solving equations by now should be pretty, I won't necessarily put it in the super easy category, but it should be pretty easy by now to solve those equations. Everybody at home ready to move on? Anybody need a little more time? At home people? I feel like I'm unmuted today with how many people aren't responding. We ready to go? Thank you, Itzel. I did see you had your hand up, or I mean you click that button for me, so I do appreciate that. All right, here we go. Let's get our first example, or actually our only example that we're going to do together. So again, the next 2 slides encompass the entire thing. So we're going to walk through this one step at a time. So we're going to use this zero product property to solve the quadratic equation. Up till this point, you've been asked to factor. That's it. Now we're going to solve it. So when you see in the directions to solve the quadratic equation in your head, I automatically need you to think those 5 steps that we just talked about. Set that equation equal to 0. Factor like we know. Set each factor equal to 0. Solve each factor. Those are the steps that we're going to follow. All right, so we're going to use the zero product property that we talked about to solve it. So we already know the very first step is that we need to make sure that one side of the equation equals 0. And here's the thing, you just took notes on those 5 steps, so as a time saver, I would not rewrite these steps on your paper, right? So if you have all 5, don't do that. Now, we know when we look at this equation, this is already set equal to 0. So step number 1, check, we did it. Step number 2 is we need to factor this quadratic equation. So set up your diamond problem. And remember the top of the diamond, we're going to do A times C. So in this quadratic, what is A? 2. And C is negative 12. So 2 times negative 12. Yep. So we know that the top needs to be A times whatever C is, and then the bottom is our B, so in this case it's 5. So then you have to think of what are those factor pairs of negative 24 that add up to positive 5. Matthew? 3. Question for you. 3 and negative 8, does that add up to positive 5? What should we change? Yeah, let's make the 3 the negative 8. It doesn't have any eraser tool. I should have just done that. All right, so negative 24. This is 5. We need this to be a negative 3. Do you see why, Matthew? Okay. And we don't have the area model set up, so we're going to put that right here. Remember this business, once you figure out those 2 factors, we know that this needs to be our first term, 2x squared. This is our negative 12. None of this right now is new, right? This is all repeat. Yeah, but it's a good review. It's been a few days since we've talked about this as a group. All right, so we know once you have the 2 numbers that you need, one of them goes in each of the other boxes. and then I've got 8x. If I am going too fast, I just need you to make sure that you remind me to just slow down a titch. So remember, now we need to find the GCF, right? So what's the greatest common factor between 2x squared and 8x? Oh, 8 and 3, -3. Sorry, Emma and Itzel, I just saw your info in the chat right now. I'm sorry, 2, and what else though? X. Good, so 2x has to go here. So we know that out of the 2x squared and the 8x, we're going to pull this 2x out. And then as usual, we say, well, if this is 2x, I know 2x times x gives me 2x squared. Ian, are you writing this down so you have an example, buddy? Jesus, you good? Okay. Well, then the next question we ask ourselves is 2x times what's 8x? Ashley? You got it. And then I go down here and say, well, I know 4 times something gives me -12. 4 times what gives me -12? Yep, you got it. And just to check, is -3 times x -3x? Yes, it is. Jesus, I'm sorry. We good? So our two factors, so up to this point, this is what we had learned up to this point, right? So our two factors are 2x minus 3 and x plus 4. So up to this point last week, this is where we would have stopped. We would have had that whole thing factored out, right? Okay, now today the new part is, because we're solving, we're not just factoring, we're solving. We're going to take each of these factors and set them equal to 0. Oh, there's the area model. So we're going to do 2x minus 3 can't remember if this continues on the next slide, is equal to 0, and x plus 4 equals 0. Let me check real quick. I'll put it back on that. Yeah, so there's our 2. So we factor the quadratic. We're going to set each term equal to 0 and then solve. There you go. It's right here. So this is where now we use our rules for solving equations, right? So what's the opposite of minus 3? Yep. So we're going to add 3, and then the opposite of adding 4 on this one is subtracting 4, right? So you're going to split it into 2 separate problems. Solve 2x plus 3 equals 0 and solve x plus 4 equals 0. So then on this one on the left, that gives us 2x equals 3. And then to get x by itself, we need to do what with that 2? Yeah, divide by 2, right? Are we in agreement that once we get this part, it's kind of like relatively easy? Yeah? Okay. Divide by 2. And then this one on the right, there's nothing else to do since x is already by itself. So we solved each term for x, and then we just write our solutions as x equals x is 1.5 and x is -4. So there's no coordinate pairs to write, there's no nothing. So we took what we knew about factoring and we added in the solving piece. Again, anytime you see what are the roots or what are the solutions, you're looking for these x values, basically. Okay? Yeah? Can you go back to the previous slide? I didn't finish writing. I sure can, Emma. I hope all that writing is still there. If not, you can, oh, it is. There you go. All right. So that is the one example that I have for you. What I would like you to do now is go ahead and head into Schoology. Refresh your screen if you've already been in there. Find your lesson 5 folder for today. And you can either work on today's assignment or work on missings from lessons 1, 2, and 3. Like I said, yesterday grades were completely updated. So let's make sure that we keep taking care of our business and getting our stuff taken care of. Yeah, Kenzie. Say that again. This last slide that we were just on. Yep, let me check with Emma to make sure she's gotten what she needs off of here. Emma, will you let me know when you're ready? There's been a request here to forward to that last slide that we just were on as well. Yeah, buddy. Yeah, look in here. Yep, in that little thing. Yep, and then you're probably going to need an extension cord, right? And is your Chromebook completely dead? Because if you want, you can charge it throughout recess and lunch, and then it should be good to go for the afternoon.
Oh, yeah. And I can just use the bonus.
Yeah, or it should be ready. Because remember, right after this, we go to recess?
Yeah, mine is like.
Yeah, it should be fine after recess and lunch, I would think. Thank you, Emma. All right. Kenzie, that one? Okay. All right, so again, you should, I see most of you here at school are already, everybody's into their Chromebooks. Nicely done. Oh, sure, that's fine. Oh, I see what you meant. I'm sorry, Jesus. Then just set each factor equal to 0. So we've, it's called scaffolding. So we've scaffolded that assignment where we've done part of it for you at the beginning, set each term equal to 0, and then solve. Yep. I suppose then you didn't need the big charging extension cord, did you, Jesus? Sorry about that. I didn't think that through very clearly. What's up, buddy? I do. It's up in the front corner. See where the orange towel is? It's kind of behind that. Thank you. Emma, yes, that's all you do. Pretty straightforward. Like I said, the only thing that's new today is setting each factor equal to 0 and then solving. Yeah, I know. Fancy terms sometimes make it sound like it's going to be super long and tedious, but good. I'm glad you think that. Anyone on the Google Meet want me to put you in a breakout room with anybody to work with? Let me know. Yeah, they're already factored for you. So I did steps 1 through 1 and 2, and then now you do steps 3 and the rest. Yep. Is that one charged, Jesus?
Yeah.
Okay. One moment, Evan.
Hello.
This one's already factored for you.
Back to you.
Yep, it's already factored. I've done the diamond, I've done these two. Yeah. Yeah. Any other questions? And do you say am I okay? Yep. Anything are you doing okay? Okay. Good, Matthew? All right. This, ready to rock? Ready to get started? Hey, those of you who are here at school, if you'd like to listen to music, you may. If anybody wants to borrow headphones, you may. Ymir, you doing okay? Okay. Let me know if you want me to check anything, okay?